In this video, we're going to have a look at an example of how to calculate the total surface area of a composite 3D shape. When you're finding the total surface area of a composite shape, there are two different methods you could use. The first one is drawing a net, which consists of the individual sides that are present within the composite shape, calculating the area of each of those shapes that make up the composite shape, and then adding all of those shapes together to find the total surface area. The second method is by using formulas that you know for total surface area of 3D shapes. First you need to do is break the composite 3D shape into smaller shapes, calculate the total surface area of each of those individual shapes. If those shapes join and some of the area of the individual shapes disappear, you need to calculate the area of the joins and then add all of the individual shapes together and subtract any joining sides. There are the two methods you can use when calculating the total surface area of a composite shape. So let's have a look at an example and see how we can apply each of these methods. So in the example, we're going to calculate the total surface area of the shape shown. Now the shape can be broken up into a rectangular prism along the bottom, and sitting on top of the rectangular prism is a cone. So we know the formula to calculate the total surface area of both a rectangular prism and a cone, and we could use that to calculate the total surface area of the composite shape, or we can draw a net and calculate each surface individually and add them all up to get the total surface area of the composite shape. I'm going to take the method of using a net and calculating each individual area to calculate my total surface area. So I'm going to start off drawing my net down the bottom of the shape, and it is a square. So the first shape I'm going to draw is the square. Now moving up from the bottom, the sides of my rectangular prism is going to consist of 4 rectangles, and each of those rectangles are going to be the same size. So coming off of my square are going to be my 4 rectangular side shapes. Next is going to be the top of the rectangular prism. Now because my cone sits on top of the rectangular prism, it is not going to be the full rectangle, but it's going to be a rectangle and it's going to have the circular base of the cone cut out. So that shape is going to be my next to be added to my net diagram. And I'll shade in the parts of the shape that I need to know the area for. And then the final shape that I need to calculate the area of to do my total surface area calculation is the curved part of my cone that is sitting on top. So that is the final shape that I need to add to my net drawing. So now that I've got all my individual shapes, before I go ahead and start doing my calculations, I need to add in my measurements. So starting with the square, it's going to have a side of 8 meters. My rectangles is going to have a length of 8 meters and a width of 3 meters. The square top with the circle cut out is going to have a length of 8 meters. Now we're not given the radius of the cone, but I can see in my diagram that the cone looks like it touches the edge of the square. So I can calculate my radius using the 8 meters side of the square. And my radius is going to be half of that, so it is going to be 4 meters. And my curved section of the cone, the slant is going to be 10 meters, and I know the radius of that cone is 4 meters. So now that I have all of my dimensions marked onto my net, I can go ahead and start doing my calculations of each of those individual shapes. So I'll start off by calculating the area of the square, which I'm going to call A. So area of A is equal to side squared, which is equal to 8 squared, which is equal to 64 meters squared. So adding that to my net diagram. Next, I'm going to move on and calculate the area of the rectangles. I'm going to call the rectangles B. So the area of B is going to equal to length times width. So substituting in those values, it's going to be 8 times 3, which is equal to 24 meters squared. So I'm going to add in 24 meters meters squared. Next, I'm going to move on to my square top with a circle cut out. So before I can calculate the shaded area that I need, I first need to calculate the area of the square and the area of the circle. So the area of the square, we already know because it's going to be the same as the square base. So that's 64 meters squared. The area of the circle is going to be calculated using pi times radius squared. So substituting in my value, pi times 4 squared, and that is equal to 50.27 meters squared. So now that I've got those two values, I can go ahead and calculate the shaded area, and I'm going to call that C. So area of C is equal to 64 minus 50.27, which equals 13.73 meters squared. So my shaded area of the top of the rectangular prism is 13.73 meters squared. So the last shape that I need to calculate the area of is the curved section of the cone. Now the formula I'm going to use to calculate that is going to be from the total surface area of a cone. So the formula for the total surface area of a cone is pi r squared plus pi r times the slant. Now the pi r squared is the part of the formula that relates to the circular base. We don't need the circular base for our composite shape. So if I remove that, that leaves me with a formula of pi rs that I can use to calculate the curved side of the cone. So I'm going to call that curved side D. So area of D is equal to pi times radius times the slant. So substituting in the values is going to be pi times 4 times by the slant, which is 10. And that is going to equal 125.66 meters squared. So I can add that in, 125.66 meters squared. Now I've got the area of all of my individual components. I can go ahead and add them up to calculate the total surface area of the composite shape. So my total surface area is going to be adding up all of those individual shapes. So the area of A plus the 4 rectangles, so 4 times the area of B plus the top with the circle cut out, so area C plus the curved section of the cone, area D. So substituting in my values is going to be 64 plus 4 times 24 plus 13.73 plus 125.66. So the total surface area is going to add up to 299.39 meters squared. So by drawing a net and breaking down the 3D composite shape into its individual components, we can go through and calculate the area and then add up all of those individual areas to calculate the total surface area of the composite 3D shape, which for our example adds up to 299.39 meters square.